Hello my scholars, you are welcome to my Myschool YouTube channel and my name is Frank. In today's video we shall be tackling JAMB CBT physics past question for the year 2024. So relax, do not go anywhere, and I'll be right back. You are welcome back to my Myschool YouTube channel. In today's video, we shall be solving question 76 to 100. So let's begin with question 76. The power of a convex lens of focal length 20 centimeter is. So let's move over to the board to provide answer to this question. So the power of a lens is given as P is equals to 1 all over focal length. Okay, but the focal length must be in meters, right? But we are told that the focal length is 20 centimeters, so we have to convert this to meters, right? But remember that 1 meter is equals to 100 centimeters. So in this case, we have to divide this by 100. That will be equals to 0.2 meters, okay? So here we're just facing that value, so that we'll be having 1 over 0.2. But remember that 0.2 is the same thing as 1 over 5, right? So this is 1 over 1 over 5. So we just move 5 upwards, and this will be equals to 5 diopters. Okay, 5 diopters. So let's return back to the screen to pick the correct option or the correct answer to this question. Okay, and that is option C, 5.00 diopters. Question 77. The charge of magnitude 1.6 times 10 raised to the power minus 19 coulombs is placed in a uniform electric field of intensity 1200 volts per meter. Calculate its acceleration if the mass of the charge is 9.1 times 10 raised to the power minus 31 kilogram. So let's move over to the board to provide answer to this question. Now remember that electric field intensity E is equals to F all over Q. Okay, so here we just make F the subject of formula based on the parameters that are given to us and what we are looking for. Okay, so that F is equals to EQ. But also remember that F is also equals to MA. Remember that F stands for force. Okay, so in this question, we actually asked to calculate for acceleration due to gravity. Okay, so we just make acceleration due to gravity the subject of formula from this equation. Okay, so that A is equals to EQ divided by M. Okay, so let's substitute the values that are given to us. So our E is 1200, then times the quantity of charge, which is 1.6 times 10 raised to the power minus 19, then divided by 9.1 times 10 raised to the power minus 31. Okay, so let's deal with the numerator first. So if we multiply, this is 1 to 3, this is to 3 decimal place, and it's positive. So if we add 3 to this place, okay, so that we'll be having minus 16. So 1.2 times 1.6, that will be equals to 1.92. Okay, so the whole numerator will be equals to 1.92 times 10 raised to the power minus 16, then divided by the denominator, which is 9.1 times 10 raised to the power minus 31. Okay, so now if we divide 1.92 by 9.1, we are going to be having 0.21099. Okay, then let's solve this place using the law of indices. So we'll be having times 10 raised to the power minus 16, then plus, because this is going to be minus minus, and minus is plus, so we'll be having plus 31, right? So minus 16 plus 31 is going to be equals to plus 15. So we're now having 0.21099 times 10 raised to the power minus 15, right? So if we move one place again, if we move one place to our right, so in that case here we'll be having another minus 1. So that at the end of the day we'll have 1.1099 times 10 raised to the power minus 16. Okay, so minus 16. So let's take this to 2 decimal places, so that at the end of the day we'll be having 2. So that we'll be having, sorry, this is positive. Sorry, this place is positive because we're having minus 16 plus 31. Okay, so that will give us plus 15, right? So plus 15, we're having plus 15. And since we move one place to our right, that means we'll be minusing 1 from here. So that at the end of the day, here we'll be having plus 14. Okay, so if we take this to 2 decimal places, we're having 2.11 times 10 raised to power 14 meter per second square. Okay, so the acceleration is equals to 2.11 times 10 raised to power 14 meter per second square. So let's return back to the screen to pick the correct answer to this question, and that is option A, 2.11 times 10 raised to power 14 meter per second square. Question 78. Calculate the power of an object which moves through a distance of 500 centimeters in 1 second on a frictionless surface by a horizontal force of 50 newtons. So let's move over to the board to provide answer to this question. Okay, remember that power is equals to work done all over time, right? And remember that work done is force times distance, then this will be T, right? So our distance, let's convert it to meter. We just divide by 100, that will be equals to 5 meters. So now that I've gotten our distance in meter, we just substitute into the given formula. Okay, so first here we'll be having 50 times 5, then divided by 1, okay, because the time is just a second. So 50 times 5, that will be equals to 250, then divided by 1, it still remains 250. Okay, so since we are solving for power, so the unit is watt. So the answer to this question is 250 watts. So let's return back to the screen to pick the correct answer to this question, and that is option D, 250 watts. Question 79. The defect of the eye lenses which occurs when the ciliary muscles are weak is A, spherical aberration. So spherical aberration occurs when there is distortion in image formation. Okay, while option B, astigmatism. So astigmatism occurs as a result of irregular shape of the cornea or lenses, okay, leading to blurred vision. While option C, we have presbyopia. Okay, so presbyopia is often associated with weakened ciliary muscle, and it is an age-related condition where the lens loses its ability to change shape, making it difficult to focus on close objects. Okay, while option D, myopia. Myopia is also known as short-sightedness, and it occurs when the eye is too long, making distant objects to appear blurry. Okay, but the answer to this question is option C, and the reason is because presbyopia is often associated with the weakened ciliary muscle. So that makes option C the correct answer to this question. Question 80. The energy stored in the above capacitor is, so let's move over to the board to provide answer to this question. So for problems on energy stored in a capacitor, we can make use of 3 formulas. Okay, E is equals to 1 over 2 QV. We can make use of this, or we can as well make use of E is equals to 1 over 2 Q square all over C, or we can as well make use of 1 over 2 CV square. So depending on the variable that are given to you, we determine the one that you will use to solve. So in the case of this question, we are given Q, right, and we're also given C. So we are going to use this to solve this problem. Okay, so energy stored E is equals to 1 over 2 Q square all over C. So we just substitute our values. So here will be 1 over 2, I say, times 3 raised to power 2, then divided by 2. Okay, so this will be equals to, of course, 3 raised to power 2 is 9, and 9 times 1 is 9. So we have 9 here. Then 2 times 2 is 4. Okay, so we just divide. So how many 4 is in 9? That would be 2.25 joules, right? Since we are talking about energy stored. So let's return back to the screen to pick the correct answer to this question, and that is option A, 2.25 joules. Question 81. An effort of 40 Newton is applied on a machine to lift a mass of 60 kilograms. Determine the mechanical advantage of the machine. We are asked to take acceleration due to gravity to be equals to 10 meters per second square. So let's move over to the board to provide answer to this question. So we know that mechanical advantage is equals to load all over effort. Okay, and we are given effort, but we are not given load. But remember that load too is also a kind of force. Okay, so, or weight in this case. So weight is W, weight W is equals to mg. right? And we are given mass to be equals to 6t, then times acceleration due to gravity, which is 10. So this will be equals to 600, right? So now that we know the value of our load, so we just substitute into the formula. So that we'll be having 600 divided by 40. So 0, we take out 0. So how many? Okay, so let's take it gradually. 4 here is 1. Okay, 2 here is 2. 2 here is 30, right? So 2 here is 1 and 2 here is 15. Okay, so the mechanical advantage is equals to 50. Remember, mechanical advantage is a ratio, so it does not have any unit. So let's return back to the screen to pick the correct answer to this question, and that is option D, 15. Question 82. The land and sea breeze is attributed to A, conduction and radiation. Conduction and radiation are all mode of heat transfer. So option B will have conduction. Conduction is the transfer of heat along a solid medium, okay, or along a solid material. While option C will have radiation, which is the transfer of heat without a material medium. While option D will have convection. So convection is a mode of heat transfer in which heat is transferred via the movement of fluid, right? So during the day, the land heats up faster more than the sea, causing the air above the land to rise and be replaced by cooler air from the sea, okay, creating what is referred to as sea breeze. At night, the land cools quicker, much more than the sea, okay, causing the cooler air from the land to move over to the sea, resulting in what is referred to as land breeze. Okay, but the answer to this question is option D, convection, because the land and sea breeze is attributed to convection. So that makes option D the correct answer to this question. Question 83. A practical application of total internal reflection is found in A, rainbow, B, diverging lens, C, converging lens, and D, fiber optics. So the answer to this question is fiber optics. So fiber optics uses total internal reflection to transfer light signals over a long distance with minimum losses. And this finds application in telecommunication. Okay, so that makes option D the correct answer to this question. Question 84. Calculate the magnetic force on an electron in a magnetic field of flux density 10 Tesla with a velocity of 3 times 10 raised to power 7 meter per second at 60 degrees to the magnetic field. So we are asked to take E to be equals to 1.6 times 10 raised to power minus 19 coulombs. So let's move over to the board to provide answer to this question. So we are asked to calculate the magnetic force on an electron in an electric field. Okay, so the magnetic force in a magnetic field is given as F is equals to Q VB sine theta. Okay, so where our theta is equals to 60 degrees, our V is equals to this value, B is this, and E is given to us as this. Okay, so we just substitute to get the value or the magnitude of the magnetic force acting on the electron. Okay, so here we replace E. Okay, so Q is equals to 1.6 times 10 raised to power minus 19, then times 3 times 10 raised to power 7, then times 10, okay, for magnetic flux density, then times sine 60 degrees. Okay, so let's multiply this out gradually. So minus 16, okay, so here we are going to apply the law of indices. So minus 19 and 7 is going to come together. So this will give us minus 12. Okay, but remember there is times 10 here. This is the same as say 1 times 10 raised to power 1. So if we add it to this becomes 8. Okay, so minus 19 minus 8, that will give us minus 11. So that at the end of the day, we just multiply 1.6 times 3, then times, so here we'll be having minus 11, then times sine 60 degrees. Okay, so here 1. So if we multiply this, we are going to be having 4.8. Okay, times 10 raised to power minus 11, then times. Now remember that this is one of those special angles. Okay, so this is sine 60 descending at 0.8660. Okay, so if we multiply everything, we'll be having 4.156 times 10 raised to power minus 11. Okay, and this, if we reduce this to 2 decimal places, we'll be having 4.16 times 10 raised to power minus 11 Newton, right? Since we are talking about force. So let's return back to the screen to pick the correct answer to this question. And that is option C, 4.16 times 10 raised to power minus 11 Newton. Do you know that you can take practice question with our JAMB CBT past questions? All you need to do is to click on the link in the description below, and that will take you to Myschool website. There you will need to download Myschool mobile app for your Android devices and Myschool software for your laptops and computers. Please go ahead and start practicing. Moving on to question 85. Calculate the upthrust on a spherical ball of volume 4.2 times 10 raised to power minus 4 meter cube when totally immersed in a liquid of density 1028 kilogram per meter cube. So let's move over to the board to provide answer to this question. So we are asked to calculate upthrust, and another word for upthrust is buoyant force. Okay, so upthrust U in this case is equals to density times acceleration due to gravity, okay, times volume. Okay, or let's put it like this. Let's say volume times density times acceleration due to gravity, G. Okay, so in this case, we are going to take G to be equals to 10 meter per second square. Okay, so we substitute the values that are given to us. So here we're having 4.2 times 10 raised to power minus 4, then times the density 1028, then times 10. Okay, so this will be equals to 4.2 times 10 raised to power minus 4. So if we put this in standard form, we're having times 1.028 times 10 raised to power 3. Then this is the same thing as say times 1 times 10 raised to power 1. Okay, so if we bring this together by applying the law of unity, we'll be having 4. So in that case, this 4 is out. So we are now left with 4.2 times 1.028. Okay, and this would be 4.3176, right? If we take this to 1 decimal place, we'll be having 4.3. Okay, so this is equals to 4.3 Newton. Remember, upthrust is the force that acts on liquid that are immersed in it. Let's return back to the screen to pick the correct answer to this question, and that is option B, 4.3 Newton. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 86. At a pressure of 10 raised to power 5 Newton per meter square, a gas has a volume of 20 meter cube. Calculate the volume at 4 times 10 raised to power 5 Newton per meter square at constant temperature. So to solve this question, we are simply going to be using Boyle's law. Okay, so let's move over to the board to provide answer to this question. So from Boyle's law, we know that P1 V1 is equals to P2 V2. So based on the data that are given to us, we're actually looking for V2. So we just make it the subject of formula. So we just say V2 is equals to P1 times V1 divided by P2. Okay, so let's substitute the values that are given to us for each of these variables. So P1 is 10 raised to power 5, then times V1 is 20, then divided by P2, which is 4 times 10 raised to power 5. Okay, so remember that this 10 raised to power 5 is still the same as say 1 times 10 raised to power 5. Okay, so this 10 raised to power 5, we cancel out this 10 raised to power 5. 4 here is 1 and 4 here is 5. Okay, so V2 is equals to 5 meter cube. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option D, 5 meter cube. Question 87. A particular household utilizes 3 electrical appliances for 6 hours daily. If the appliances are rated 80 watts, 100 watts, and 120 watts respectively, calculate the electrical bills paid monthly if an average month is 31 days. And we are asked to take 1 kilowatt hour to be equals to 24 naira 08 kobo. So let's move over to the board to provide answer to this question. So this question is under calculation for energy consumption. Okay, so remember that energy consumption E is equals to power times time, right? Power here must be in kilowatts. Okay, so first of all, let's get the total powers. So for the three appliances, total power will be equals to 80 plus 100 plus 120, and this will be equals to 300 watts. Okay, so if we convert this to kilowatts, it's just for us to divide by 1000, right? And this will be equals to 0.3 kilowatt, right? Now let's get the energy consumption. E in this case will be equals to 0.3 then times T, which is times 6, and this will be equals to 1.8 kilowatt hour, right? Now in this question we are told that the appliances or the energy consumption is for 31 days. Okay, so let's get the amount of energy consumed in 31 days, and that will be equals to 1.8 times 31. Okay, and this will be equals to 55.8 kilowatt hour. This is the amount of energy consumed for 31 days, okay, which is approximately 1 month, right? So let's calculate for the amount paid now for this amount of energy consumed for 31 days. Now remember that we are told that we should take 1 kilowatt hour to be equals to, okay, this is naira, to be equals to 24 naira 08 kobo, right? So since 1 is equals to this, then 555 will be equal 5.8 kilowatts, okay, will now amount to times 24.08, and this will be equals to 1000, okay, 1343 naira 66 kobo. Okay, so this is what the household will pay for 31 days for a month for this amount of energy consumed. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option C, 1343 naira 66 kobo. Question 88. A body is pulled on a horizontal surface with a rope inclined at 30 degrees to the vertical. If the effective force pulling the body along the horizontal surface is 15 Newton, calculate the tension on the rope. So let's move over to the board to provide answer to this question. So this question is under the vector, okay, where you have to resolve vector into its components, okay, horizontal and vertical component. So if you want to learn more about this topic, we've actually covered that in our physics topic by topic video lessons. So you can click on the link below, that will take you to my school website. There you can subscribe to enjoy this video, to learn about this topic and other topics also. Okay, so let's provide answer to this question. So in this question we are told that the rope is inclined at angle 30 to the vertical. Now remember, if we want to resolve forces into its component, okay, into its component axis. Now remember that if the object is inclined, okay, to the horizontal, let's say the force is inclined to the, or the rope is inclined to the horizontal. Now the horizontal components will be equals to F. Okay, in this case, let's use tension in the rope, T sine cos theta. Okay, this is when the rope is inclined to the horizontal. Okay, so your F, the y component will be equals to T sine theta. Okay, but then if you were told that the angle is inclined to the vertical, this is when it is inclined to the horizontal. But if the angle is inclined to the vertical, then the reverse will be the case. So the F component will now be equals to T sine theta, while the horizontal component will now be T sine theta, while the y component, okay, will now be T cos theta. Okay, so in this case we are told that the rope is inclined with the vertical, so we are making use of this. Okay, but remember in this question we are told that the effective force, okay, which is the force that actually brought about the movement of the body along the horizontal surface, okay, is equals to 15 Newton. Okay, so in that case we already have the F component of the force, the horizontal component of the force, so we just substitute it here. So we are having 15 is equals to T sine 30. Okay, remember the angle is inclined at 30 degrees to the vertical. Okay, but remember that sine 30 is one of those special angles. So sine 30 is the same thing as 1/2. Okay, so here we'll be having 15 times t times 1 over 2. So 15, sorry, this is equals to, sorry, okay, so 15 is now equals to t all over 2. Now we are looking for t, so we just cross multiply so that t is equals to 15 times 2, and this will be equals to 30 Newton. Okay, so the tension in the rope is equals to 30 Newton. So let's return back to the screen to pick the correct answer to this question, and that is option A, 30 Newton. Question 89. Newton's law of cooling is valid only for A, small temperature range, B, large temperature range, C, free flow range, D, presence of heat source. So the answer to this question is option A, small temperature range. So according to Newton's law of cooling, the law states that the rate of heat loss of a body is directly proportional to the difference in temperature between the body and its surrounding, provided that this difference in temperature is small. Okay, so that makes option A the correct answer to this question. Question 90. When thermal energy in a solid is increased, the change in state is called A, melting, B, evaporation, C, freezing, and D, condensation. Okay, so the answer to this question is melting. Okay, so when thermal energy in a solid, more or less like say increasing the energy of a solid, when heat is added to a solid substance, after some time the body will start undergoing melting. Okay, so when thermal energy in a solid is increased, the change of state is actually called melting. While for option B, evaporation actually occurs at all temperature. So irrespective whether the temperature is increased or decreased, evaporation will still occur because it occurs at all temperature. While for freezing, you have to remove heat, so not increasing heat. Condensation, the same thing, you are removing heat. Okay, so the correct answer to this question is option A, melting. Question 91. I clear, I sharp, I poor, IV dark. Which of the above happens when the hole of a pinhole camera is diminished? So A, we have I only, B, I only, C, I and I only, D, I and IV only. So the answer to this question is option B, I only. So when the pinhole of a camera is diminished, the image becomes sharp. Okay, and this is because reduced hole means you are reducing the amount of light entering the camera, leading to a sharper image. Okay, so that makes option B the correct answer to this question. Question 92. A blacksmith heated a metal whose cubic expansivity is 3.9 times 10 raised to power minus 6 per Kelvin. Calculate the area expansivity. So let's move over to the board to provide answer to this question. You must not forget that cubic expansivity is equals to 3 linear expansivity, right? So here, let us calculate for the linear expansivity, right? Since our cubic expansivity is given to us to be 3.9 times 10 raised to power minus 6, so this will be equals to 3 alpha. So here we can make alpha the subject of formula by dividing both sides by the coefficient of alpha, which is 3. So alpha will now be equals to 3.9 times 10 raised to power minus 6 divided by 3. Okay, so 3 in 3 will be 1, then 0.3 in 9 will be 3, then times 10 raised to power minus 3, times 10 raised to power minus 6 per Kelvin. So now that I've gotten the value of the alpha, but remember that for area expansivity, okay, beta is equals to 2 alpha. Okay, so for us to find the value of beta, we just substitute the value of alpha that is given to us. So in this case, we're having 2 times 1.3 times 10 raised to power minus 6. Okay, so if we multiply, we're having 2.6 times 10 raised to power minus 6 per Kelvin. So the value of the area expansivity is equals to 2.6 times 10 raised to power minus 6 per Kelvin. So let's return back to the screen to pick the correct answer to this question, and that is option B, 2.6 times 10 raised to power minus 6 per Kelvin. Question 93. The unit of impedance is So we define impedance as the effective resistance to a current flow around a circuit containing both AC resistance and AC reactance, and is actually measured in ohms, okay? And option A is the symbol of ohm. So that makes option A the correct answer to this question. While option B, T, actually there stands for Tesla, and that is the unit of magnetic flux density. While C here, okay, we have H, and H there stand for Henry, and it is the unit of inductance. While D stand for watt, which is the unit of watt. But the correct answer to this question is option A, ohms. Question 94. If the displacement of a car is proportional to the square of time, then the car is moving with A, uniform acceleration, B, uniform velocity, C, increasing acceleration, and D, decreasing acceleration. So the answer to this question is uniform acceleration. So when the displacement of a car is proportional to the square of times, it shows that the car's velocity is increasing at a constant rate, and this is a characteristic of uniform acceleration. Okay, so that makes option A the correct answer to this question. Do you have any question to ask? If yes, please feel free to ask your question by clicking on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our army of solution providers will provide solution to all your questions within a short period of time. Moving on to question 95. The equivalent capacitance of the capacitors in the circuit above. So let's move over to the board to provide answer to this question. So this is the circuit that is given to us, and if you can, as you can see, the circuit is a combination of series and parallel capacitance. So these two here are parallel, while these two are in series. So first of all, what we are going to do is to calculate for the effective capacitance in parallel, and then for the effective capacitance in series. Then we'll now add everything together to give us the effective capacitance of the circuit. Okay, so capacitance, okay, so we will not avoid the time. Capacitance in parallel will be equals to, which is this two, just C plus C, that will be equals to 2C. Okay, while capacitance in series, in this case, will be equals to, which is this two, 1 over 2. Of course, we know that that is 1 over C is equals to 1 over C plus 1 over C. So this is for the equivalent. Okay, so if we are to do this together, we'll be having 2 all over C. Right? We'll be having 2 all over C. But since we are looking for the effective capacitance, so in that case, our C effective will now be equals to C over 2. Okay? So now let's get the effective capacitance of the circuit. Okay? So in that case, we are going to be adding the capacitance in parallel plus the capacitance in series. So that will give us the effective capacitance of the circuit. Okay? So let's do that. Effective capacitance in the circuit, or of the circuit. Okay, so in that case, we'll be having 2C plus C all over 2. Okay, so let's solve this little fraction. So LCM here is 2, right? So 2 into 1 into 2 is 2. Then 2 times this will give us 5. Will give us 4C. Okay, will give us 4C. And 2 into 2 is 1. 1 times C is plus C. Okay, so in this case, we'll be having 5C divided by 2. Okay, so the effective capacitance of the circuit is equals to 5C over 2, or you can say 5 over 2 times C. Okay, so it's still the same thing. So let's return back to the screen to pick the correct answer to this question, and that is option A, 5 over 2C. Do you have better steps or solution to solving any of this question? If yes, please do well to share this information with us by reaching down to the comment section below to comment the question number and the solution you wish to share. Question 96. Using the diagram above, calculate the relative density of S if the density of methanol is 800 kilogram per meter cube. So let's move over to the board to provide answer to this question. So first of all, let's convert this 800 kilogram per meter cube to grams per centimeter cube, because the height is given to us in centimeter cube. Or you can as well convert the height given to us in centimeter cube to meter, whichever way. So if we convert this to grams per centimeter cube, we'll be having 0.8 gram per centimeter cube. So what I did is just to divide by 1000. Okay, but remember that for a Hertz apparatus at equilibrium, the pressure on both arms are equal. So let's say this is pressure of the methanol, okay, is equals to pressure of liquid X. But remember that pressure is equals to density times height times acceleration due to gravity. Okay, here too is density, which is density of X, okay, times the height of X times acceleration due to gravity. So acceleration due to gravity, we cancel out acceleration due to gravity. Remember, this is density of methanol. Okay, so since we are looking here, we want to actually calculate for the density of liquid S. Okay, so the density of liquid S all over the density of methanol will be equals to the height of methanol all over the height of liquid S. So let's substitute our values. So this is density of liquid S all over that of methanol 0.8. That will be equals to the height of methanol, okay, is 7.1 all over the height of liquid S, which is 14, okay, which is 14.1. Okay, so if we cross multiply to get the density of liquid S, that will be equals to 0.8 times 7.1 divided by 14.1, and this will be equals to 0.4 gram per centimeter cube. Okay, so this is the density of liquid X, right? But remember that relative density in this case will be equals to the density of liquid X, okay, all over the density of methanol. So we just, since we are looking for the relative density of liquid S, so we just substitute this value. So that we'll be having 0.4 divided by 0.8, and this will be equals to 0.5. Remember, relative density does not have units. So let's return back to the screen to pick the correct answer to this question, and that is option B, 0.5. Question 97. The force of attraction between molecules of the same substance is A, cohesion, B, capillarity, D, adhesion, and D, surface tension. So the answer to this question is option A, because the force of attraction between molecules of different substances is called cohesive force. Okay, so cohesive force is the force that enables molecules of the same substances to stick together. Okay, while option B is called capillarity. Okay, so capillarity simply refers to the ability of a liquid to flow in a narrow space without the assistance of external force. While option C, adhesion is the force of attraction between molecules of different substances. Take, for example, the molecules of water and glass. In fact, that is the reason why water actually sticks to glass. Okay, this force is the reason why water sticks to glass. While D, we have surface tension. Okay, so surface tension is the cohesive force on the surface of liquid that causes the liquid to act as if it is a stretched elastic membrane. Okay, but the answer to this question remains option A, cohesion. Question 98. If the pressure on an enclosed gas is doubled and its temperature rises from 27 degrees Celsius to 127 degrees Celsius, then its volume will, so let's move over to the board to provide answer to this question. So these are the parameters that are given to us in the question. So here I said let P1 be equals to P, so that P2 becomes 2P, right? That is what they told us in the question. Now remember, our temperature is given to us in degrees Celsius, but here we have to convert it to Kelvin by adding 273 to it. So if we add 273 to 27, that will be equals to 300. If we add 273 to 127, that will be equals to 400 Kelvin. Okay, so here we are to use the general gas law equation where P1 V1 over T1 is equals to P2 V2 all over T2, right? So here we are looking for V2, so we just make it the subject of formula. So that we'll be having V2 to be equals to P1 times V1 times T2 all over P2 times T1. Okay, so let's impute the values of each of these variables that are given to us in the question. So our P1 will be equals to P, then times V1 remains constant, remains there. Okay, not a constant but remains, then times T2, which is 400, over P2, which is 2P, then times T1, which is 300. So 0, we take out 0, okay? 2 here is 1, so we have P left here, then 2 here is 2. Okay, so this P, we take out this other P, so that our V2 is equals to 2 over 3 V1, okay? But now, remember in this question, we are asked to calculate, to tell them what the volume will be, okay? So now, we actually want to get this volume. What we do to get the change, it will be equals to V, change in V will be equals to V1 minus our V2, which is this value, okay, 2 over 3 V1, okay? So if we operate this, if we solve this little fraction here, we'll be having 1 over 3 V, okay? So let's move over to the screen to pick the correct answer to this question, and that is option D, decrease by 1/3 of the initial volume, okay? Now the reason why we have to calculate for this change is because so that we can actually get the actual amount of the decrease, okay? Because if we say it decreased by 2 over 3 V1 to be our final answer, that means we are saying that the final volume is equals to 1 over 3 of the initial volume, which does not agree with what we got from our calculation. Okay, so we have to look for the change to get this. So this represents, having this as the decrease means that what we actually got, our calculation is correct, meaning that the final volume, okay, is actually 2 over 3 of the initial volume. Okay, so that is why we choose option D as the correct answer to this question, decrease by 1 over 3 of the initial volume. Question 99. The simple form of the lead acid accumulator often has a negative pole of A, zinc peroxide, D, lead peroxide, C, sulfuric acid, and D, lead plate. Okay, so the lead acid accumulator is just your car battery, okay, and your car battery consists of 2 electrodes, positive and negative, that is dipped, okay, in a liquid, in that case referred to as the electrolyte, and in that case the electrolyte is sulfuric acid. Okay, so the positive electrode, okay, is actually lead dioxide, while the negative electrode is lead. Okay, so that makes option D the correct answer to this question, lead plates. Question 100. A monochromatic light is one that A, can undergo dispersion, B, cannot be refracted, C, has one wavelength, D, has many wavelengths. So a monochromatic light is a light that has only one color. Okay, and only one color implies that the light has just one wavelength. Okay, so that makes option C the correct answer to this question. So for option A monochromatic light cannot undergo dispersion, although that is not the answer to this question. Okay, but a monochromatic light cannot undergo dispersion because it contains only one light or has only one wavelength. Okay, while option B cannot be refracted, a monochromatic light can be refracted. Okay, while option C, which is the answer to this question, has one wavelength, while option D, no, it does not have many wavelengths but has only one wavelength. So that makes option C the correct answer to this question. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos.